So this one is 10-9. On a 6-person bowling team, only 4... Okay, we're going now, you guys. Okay, there's a 6-person bowling team and only 4 players bowl in any game. Refer to the math notes box for help with this problem. So I'm going to do that in a minute. It has a formula for me. How many different 4-person teams can be made if the order in which they bowl does not matter? So this is what we call a combination when the order doesn't matter. And I know that we haven't really taught you about this. This is something that came from Integrated 2 that I'm pretty sure you guys skipped. Sorry.
I get that from the book.
Yeah. Well, yeah. But that's why they're saying, like, let's look in this math notes box. So there's these things called permutations and combinations. And so permutations are, actually I'll give you a short little lecture on permutations and combinations. So here's a permutation. And then I'll say the order matters. And then here's a combination. And I'm going to say the order doesn't matter. And you guys probably don't know what I mean yet, but I'll tell you about that. Order doesn't matter. Okay, so if I wanted a permutation of something and the order matters, that would be like if I had 3 numbers, the number, I don't know, let's just say the number 3, 4, and 5. Let's say I have these 3 numbers. How many 2-digit passwords can I make with these numbers? Well, I can make a 34, or a 35, or I can make a 43, or a 45, or I can make a 53, or a 54. So the order, if the order matters, then the 34 isn't the same as the 43, right? Like, let's say it's a little password. It's your, let's say you only need a 2-digit password. So I could say the permutation of these 3 things taken 2 at a time is, there's 6 different ways. But if I wanted combinations, a combination of 3 different digits taken 2 at a time, well, I'm not going to have as many if the order doesn't matter. Because the 34 and the 43, those are like the same. And the 35, like this one and this one, are the same. I'm only going to have 3 combinations. So here's an example where the order doesn't matter. If I have Brian, who else is in, and Tiffany, and Alex, I know I'm going to A and Y, and Alex, if I have a B and a T, B, T, A. How many 2-person teams can I have? Well, I could have Brian and Tiffany, or I could have, I don't know, Brian and Alex, or I can have Tiffany and Alex. Is there any other combinations of 2-person teams I could have? So because it doesn't matter if I pick Tiffany first and then Brian second, that's still the same team, right?
Yeah.
So that's the difference between if it's a permutation or a combination when the order doesn't matter. So there's formulas for permutations and there's a formula for combinations. So the combination one is, let's do the combination one first. It's n factorial. I'm just grabbing this right out of your math notes box. And this is n minus r, and I'll tell you what the r's and n's are, factorial, times r factorial. Okay, this thing here is your formula that you got out of your math notes box for the combination of n things taken r at a time. What does that mean? That means n is how many different things there are. Like in this case, the things were people. There was 3 different people. And the R is for how many you're having at a time. Like how many, so that would be 2. So this would be the combination of 3 people taking 2 at a time. Okay, and then what does factorial mean? Factorial is, I know you guys have a calculator button and you all want to go push your calculator button, but factorial it counts backwards by integers. Like the factorial, 3 factorial would be 3 times 2 times 1. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Get the idea? 12 factorial would be 12 times 11 times 10 times 9 times 8 times 7 times 6. So, but when you're doing these problems, I would discourage you from using your factorial buttons because this is fractions and stuff will cancel out.
So then should we just do it one at a time?
Yeah.
Well, I would go like, for this problem right here, I have 3 things taken 2 at a time. I'd go 3 factorial is 3 times 2 times 1, right? And then n minus r, that's 3 minus 2, that's 1 factorial, which is just, and 1 factorial is just, by definition, they just call it 1. I know it's kind of weird, but it's just 1. And then r factorial, that's 2 factorial. Well, that's 2 times 1. Well, see how the 2 times 1 goes away? And then we said 1 factorial is 1, so we end up with 3 here. But then if I do permutation of n things taken r at a time, it's the exact same thing as a combination, but it doesn't have this little extra r factorial on it. So it's just going to go n minus r. And you can Google that if you want these formulas. And let's see if we get the right answer here. We had 3 digits, so it's 3 factorial. And then we had n minus r, so they're taking 2 at a time, so 3 minus 2 factorial. So that's 3 times 2 times 1 over, this is 1 factorial, which is 1, and I get 6. And that's what we said it was when we listed it out. So that's the longest video ever. I'm going to